Today, we want to continue finding the interval of convergence for a power series. Let's remind ourselves that there are three possibilities for the interval of convergence, and we can categorize them by the radius. The radius of convergence could be 0. What this means is that the power series only converges if we zero out all the terms. The second case, the radius could be finite but non-zero. So it'll always be between a minus r and a plus r, where r is the radius of convergence. The initial thing that will drop out of the ratio test will be the absolute value of x minus a is less than r, where a is in the middle and r is the radius. What we have to remember is that the ratio test does not know what's going on when the limit from the ratio test is equal to 1. That's when we have to check the endpoints because something else is going on. That's where the polynomials are going to show up. And so that's where the ratio test is going to come up with a limit of 1. The other thing is that the radius could be infinite. That is, the power series could converge for all real numbers. The basis for our interval of convergence is a geometric series. Our basic interval of convergence is going to be based on the geometric series. Remember that the series, as n goes from 0 to infinity, of a times r to the n, we actually know the sum of a geometric series. It's a over 1 minus r. But this is if r, or if the absolute value of r is less than 1 and diverges otherwise. So when we're looking at a power series, we can the power series will have a geometric aspect to it. So when we're looking at a power series, we have the sum as n goes from 0 to infinity of some coefficients Cn times x minus a to the n. So that x minus a to the n is like the geometric part. So we start by thinking absolute value of x minus a to the n, or absolute value of x minus a is less than 1 is going to be our interval of convergence. That's kind of like our baseline. Then we look at Cn and see if Cn is going to change anything about that base interval of convergence. So this is what I call the base model, the base interval of convergence. Your base interval of convergence is the absolute value of x minus a should be less than 1. That's everything within 1 unit of a. Then we look at Cn to see if Cn has anything to change. Does Cn change anything? What does the Cn do to the basic interval of convergence? And we're going to look at this in 3 categories. We're going to look at this in the polynomials, the exponentials, and factorials, and the effects that each of those 3 types can have on the basic interval of convergence. We're also going to look at Cn and think about what's going on in its numerator and the denominator. So that's where it starts. Cn has a numerator and denominator. we're going to consider the numerator and the denominator of Cn. And then we have the following basic ideas. Polynomial factors in Cn affect the endpoints of the interval of convergence. Any polynomial factors in Cn only influence the endpoints of the interval of convergence. If we think about the ratio test is blind to polynomial factors. So the polynomial factors are only going to come into play when the limit from the ratio test is equal to 1, and that's at the endpoints of the interval of convergence. So I say polynomial factors influence the endpoints of the interval of convergence. And I justify this by reminding you that the ratio test is blind to polynomial factors. Exponential factors will influence the radius of convergence, will influence the finite radius of convergence. So polynomials first, exponential factors exponential factors will influence the finite radius of convergence. And then, so exponential factors are what's going to adjust your finite radius of convergence. Polynomial factors are going to tell us what's going on at the endpoints. To get a 0 radius of convergence or an infinite radius of convergence, we're going to see factorial factors. Factorial factors open up the possibility of a 0 radius or an infinite radius. So factorial factors may produce a 0 radius or an infinite radius. Not necessarily if there are other factorial factors to balance out some factorial factors in the numerator and the denominator, then we might not get a 0 or an infinite. So it still might be finite and non-zero, but factorial factors may be. So with factorial factors in our power series, it still might be that there is a finite, a non-zero finite radius of convergence. And then we just look at the polynomial factors, exponential factors, and factorial factors in the numerator and the denominator. All right. Let's check out some examples. Remember, we can find the interval of convergence by running the power series through a ratio test and checking the endpoints. We want to avoid running the power series through the ratio test and checking the endpoints. We want to be able to do that by looking at it and not just have to do the thing all the time. So let's look at some examples. Let's suppose that we have x minus 3 to the n over n squared. So when I look at this, I see my basic interval of convergence is going to be the absolute value of x minus 3 has to be less than 1, because that's the geometric part. The n squared is we're only going to think about the endpoints for the n squared. And that's those are the only factors that we have. So I'm going to just write down my basic interval of convergence. Where the absolute value of x minus 3 is less than 1. That's my basic interval of convergence. But I want to check the endpoints. So the absolute value of x minus 3 less than 1 means we're looking at everything within 1 unit of 3. So if 3 is in the middle, we got 2 down at the bottom and 4 above. So we need to know what's going on at the endpoints, and it's the n squared that's going to tell us what's going on at the endpoints. So when x is equal to 2, we're going to get a negative 1 to the n over n squared. So when x equals 2, our power series looks like the sum of 2 minus 3 to the n over n squared. 2 minus 3 is negative 1, so we get negative 1 to the n over n squared. And this series is absolutely convergent. It's not the alternating that matters, it's the n squared that matters. So we look at this and we see this is absolutely convergent. The alternating is not what gets us convergence. The alternating is just extra. We don't need the alternating. It's the n squared that's making the difference. At x equals 4, we get the non-alternating version. So this would be the series 4 minus 3 to the n over n squared. And that's just going to be the series 1 over n squared, which is absolutely convergent. So what this means is that the power series converges when x equals 2 and converges when x equals 4. So in our interval of convergence, I want to make sure 2 is included and 4 is included in the interval of convergence. So I can say the interval of convergence is the absolute value of x minus 3 is less than or equal to 1. Less than or equal to means both endpoints are included. So we have the or equal to part since both endpoints are included. We could also write this as x is between 2 and 4, including 2 and 4. So we can describe it as a compound inequality or an absolute value inequality since both endpoints are included. Let's suppose that I put some more factors on there and see how things change. So here we had x minus 3 to the n over n squared. Let's suppose we have the sum x minus 3 to the n over 5 to the n times n squared. So looking at this, I see there's a 5 to the n. That's going to affect any finite radius of convergence. The n squared is still just going to be the endpoints. So n squared is still just going to be about the endpoints. And the 5 to the n could affect the radius. The exponential stuff could change the radius. If we look at the 5 to the n, we've got it underneath the x minus 3 to the n. What this means is that the common ratio is not just x minus 3 like it was in the previous example. The common ratio is x minus 3 over 5. So our basic interval of convergence will be the absolute value of x minus 3 over 5 has to be less than 1. I'm just going to use the fact that we can distribute exponents over factors and say x minus 3 to the n over 5 to the n is x minus 3 over 5 to the n.
Professor,
Yes.
why wouldn't you include the n squared?
Because the n squared is not part of the exponential stuff. N squared, I'm just going to put that aside because that's still just going to affect the endpoints.
Got it.
In the same way that I just grabbed the x minus 3, the geometric stuff, I just identify the common ratio, ignoring any polynomial factors.
Got it. Thank you.
I'm just acting like a ratio test. Ratio test does not see this n squared business. Ratio test says, look at this cool exponential stuff. That's the stuff that I care about. And then this n squared is down here. It's like, well, hey, what about me? And the ratio test is like, well, I don't care about you, n squared. I'm going to leave you for the comparison tests. And n squared is like, feeling sad. But then n squared remembers, hey, there are 2 comparison tests and only 1 ratio test. So I'm technically going to be more popular. So what we want to do is get the x minus 3 part and multiply by 5 to solve for the x minus 3 part. So then it looks like our interval of convergence. So that's the effect that this 5 to the n had on the radius of convergence. A 5 to the n in the denominator made the radius of convergence equal to 5. So the 5 to the n in the denominator makes the radius of convergence equal to 5 when we solve for the absolute value of x minus 3. So now we got the center and the radius. We need to use that to figure out what the endpoints are so that we can check the endpoints. And that's where the n squared is going to come into play. So in the middle, we've got a 3. 3 minus 5 is negative 2. And 3 plus 5 is 8 or something. The ratio test does not know what's going on when the limit is equal to 1. So if we look at when x equals 2 and when x equals 8, negative 2 and 8, then the ratio test is going to give us a value of 1 there. And so we won't know what's going on. So we check those. So when x is equal to negative 2, our power series is the sum of -2 minus 3 to the n over 5 to the n times n squared. Notice that when we plug in the -2 in the numerator, we get -2 minus 3, which is -5 to the n over 5 to the n. And we can simplify the 5 to the n. This is why I recommend not just doing the ratio test automatically from the beginning, because it's always going to behave very predictably. This series is absolutely convergent. So the power series converges when x equals -2. So -2 is included in the interval of convergence. We're going to see the same thing at the other end, because on one end we get the alternating part, on the other end we get the not alternating part. So when x is equal to 8, we get the sum of 8 minus 3 to the n and so we'll have 5 to the n over 5 to the n times n squared, which is just the sum 1 over n squared, which is still absolutely convergent. So 8 is included in the IOC. The interval of convergence. So my interval of convergence, just like before, is I can do a less than or equal to because both endpoints are included. I can say it's from -2 is less than or equal to x is less than or equal to 8 in a compound inequality, or since both endpoints are included, I could say the absolute value of x minus 3 is less than or equal to 5 as an absolute value inequality. Now we just need to start looking at variations of this theme. I'm just going to start moving things from numerator to denominator, and I'm going to start changing the polynomial parts. And then we'll see how factorials come into play. Any questions on this example? While I wait for the gel to dry on this page. I should move this around. It becomes like a Blair Witch Project type of thing. Remember when Blair Witch, I don't know if anybody has seen Blair Witch Project, but it was like, well, what if we just made a movie just using like terrible camcorders and everything was like moving all the time? I couldn't watch the movie because everything was moving like this and I was getting motion sickness. The movie itself wasn't exactly frightening. It was just like, it was just moving around too much. Some TV shows do that. I think NYPD Blue is the one that started off. It's like, well, what if instead of the camera just being in one place, we like moved it back and forth? Just kind of like randomly. There was one of the Marvel shows. It was like on Netflix. I think it was Cloak and Dagger. They did the same thing where the camera just kept moving and I could not watch the show. And I wasn't actually getting sick. I was just too distracted by the fact that the camera just wouldn't stay. I don't want to move my camera, but that the camera wouldn't stay still. It's like you guys have been playing too much video games. It's like when your character is running in a video game in a first person, it's like doop, ba-doop, 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 ba-doop. Next time you're out running, keep in mind that your focus stays where it is. So all right, so what are we talking about? Ah, yes. So last time we had a series. So let's do another example. And I'm just going to change things up just a little bit. I'm going to say the 5 to the n, move it into the numerator, because we know that the exponential stuff, we'll leave the n squared where it is. The 5 to the n part is going to affect any finite radius of convergence. And the way we think about this is to just pull out the geometric part and think if this n squared wasn't there, because the n squared is still only about the endpoints. So if we just ignore the n squared parts and just think of the radius of convergence for the geometric part, I have the absolute value of 5 to the n times x minus 3 to the n has to be less than 1, because that's geometric series. Oh, we get rid of the n's. Sorry, the n is not part of the common ratio. Then if we solve for the x minus 3, the absolute value of x minus 3, we get the absolute value of x minus 3 has to be less than 1/5. So we got a radius of convergence of 1/5 because the 5 to the n was in the numerator. Because we want to think about think in terms of a geometric series when it comes to and we want to use that. We want to leverage that knowledge. So this is everything within 1/5 of a unit of 3. So I'm going to draw my interval of convergence, find my endpoints. So in the middle, we've got a 3, and I've got this little tiny radius of 1/5. I know I draw the radius the same size every single time. So it goes up to 3 and 1/5 and down to 2 and 4/5. Oh, it wasn't Italian realism, it was French New Wave. I'm not familiar with like eras of movie making. I just watched the movies. It's especially funny because the amount of technology we threw at the idea of getting a camera to move and not having the picture move, like stabilize a camera. We do all that, and then the French come along. It's like, oh, what if we just let the camera move? And then NYPD Blue happens, and then the Blair Witch Project happens.
Or the extreme close-ups on Perry Mason.
Oh yeah, I've been watching some of the old Perry Mason where they just started. They didn't know how to use cameras at the time, and so the camera didn't have really a wide field of view, and so they'd have these static 2 shots where people are standing uncomfortably close to each other, and the way they had to set up shots. They had to kind of like line everybody up and use the depth of field. Now they just have easy mode where they just have like a really wide screen. But before then, it's like, oh, everybody has to fit into this. So squeeze closer together, closer, closer, just like you're taking a group picture for some committee or something like that. So we got to check the endpoints at 2 and 4/5, and we're going to see some things that are going to happen all the time. So when x is 2 and 4/5, our series is going to be, we're going to have a 5 to the n, and then we'll have a 2 and 4/5 minus 3 to the n. This is going to be the alternating side. Because when I plug in one of the endpoints, the 2 and 4/5 minus 3 is going to be a negative 1/5. So I'm going to end up with a sum. We'll have a 5 to the n times a 1/5, a negative 1/5 to the n. And all that exponential part that was determining our radius of convergence cancels out. And we just get the series negative 1 to the n over n squared. Absolutely convergent. 2 and 4/5 is in the interval of convergence. Now, very predictably, what's going to happen on the other end is that we're going to get a 1 over n squared. So let's see that happen. Sometimes it's not about knowing what's going to happen, it's about seeing what's going to happen. That's why we go to the movies anyway. It's not about knowing what's going to happen. It's about watching it happen. We know that the boat sinks. It's not about the boat sinking. It's about the stuff that was going on when the boat sank. And even though there was tons of interesting stuff that was actually going on, let's make some stuff up. So predictably, we see what happens. The 5 to the n, plugging in 3 1/5 gives us a 1/5 to the n, and the 5 to the n and the 1/5 to the n cancel out, and we have the non-alternating side. So both the endpoints are included. That means I can write a compound inequality for the interval of convergence. 2 4/5 less than or equal to, because it's included, less x, and then that's less than or equal to 3 1/5. Since it's so here's a compound inequality describing the interval of convergence, or since both endpoints are included, I could say it's x minus 3 is less than or equal to 1/5. We only get to write an absolute value inequality when both endpoints are included, because we have the same inequality style. Perry Mason on TV 20 is where I started watching Perry Mason as well. So let's keep making adjustments to see what's going to happen. So now you'll notice that something is going to change in the endpoints for this power series. Because I kept the 5 to the n, I kept the x minus 3 to the n, and I just have an n in the denominator. N in the denominator, that's the polynomial factor. That's still just the endpoints. But something should be different about the endpoints with this n. So that's still just about the endpoints. Even though it doesn't have a radius of, a common ratio, we think about what would happen if we had a common ratio, and we say the absolute value of 5 times x minus 3 has to be less than 1. And that gives us the same base interval of convergence, x minus 3 has to be less than 1/5. And that gives us the same 2 4/5 and 3 1/5. So that's still everything between, strictly between 2 4/5 and 3 1/5, with 3 in the middle. But we still have to check the endpoints. Now something is different going to happen. Something different is going to happen because I changed the thing that would change the endpoints, that would affect the endpoints. So let's see what happens at the endpoints. So when x is 2 4/5, our power series looks like 5 to the n times 2 4/5 minus 3 to the n over n. The 2 4/5 minus 3 is still a negative 1/5 to the n. And so when I simplify 5 and the 1/5, I get a negative 1 to the n over n. So I get the alternating harmonic series at the 2 4/5 endpoint, which is conditionally convergent. Here, we need the alternating. It's the alternating that gives us convergence. Here, it's the alternating that's giving us the convergence. But convergence is convergence. 2 4/5 is in the interval of convergence. Now the other, so that's one interesting change. We've got conditional convergence at one of the endpoints. So we know if we start messing with the order of these terms at 2 4/5, we can get different values, but we're still getting a value, depending on the arrangement. It can be whatever we want. At the other endpoint, at 3 1/5, this should also be very predictable. What's going to happen is we're going to get the series 1 over n, and so it diverges, and 3 1/5 will not be in the interval of convergence. Let's see that happen. Because it's not about knowing what's going to happen, it's about seeing what's going to happen sometimes. And in the case of a math class, it's about seeing it happen over and over and over again. Until even though now you understand what's going on, when your kids are going into the same class, they won't, and you won't be able to explain it to them because you haven't had to think about it for a very long time. And then, since that will hurt your pride, you'll just complain about the school. So when x is 3 1/5, the power series looks like 1 over n, which diverges. So 3 1/5 is not in the interval of convergence. So I don't get to use an absolute value inequality. I can just say the interval of convergence 2 4/5 is included, so I'll put the or equal to there. But 3 1/5 is not, so I will not be able to put the or equal to. Since my inequality symbols don't match, we don't get to use an absolute value inequality. The inequalities don't match. One is or equal to, the other one is not or equal to. So we don't get to use an absolute value inequality in this case. All right, so next time, which will not be until, I'm hoping to be able to record on Wednesday morning, but I'm going to be 3 hours ahead of y'all, so just check the YouTube channel. Then I'll make an announcement about when I can have a virtual office hour. So check for the recordings and the notes on Canvas. Tomorrow there won't be anything, but there should be something up on Wednesday. All right, that's going to do it for today. Everybody have a good day, and thanks for playing.